Okay, so let's get started. Hello and welcome everyone to the PIRE webinar on Google Cloud for high performance computing. So today's webinar is about an hour long for presentation, but we should also have time to open questions and discussions. So before we start, just a little bit of housekeeping. Please open your chat window on Zoom so that you can type out questions during the webinar. And we will try to address all of them by the end of the webinar. And also please mark your calendar for the next PIRE webinar. So that will be February 12th. And we will talk about rendering large data set in that webinar. So without further delay, I would like to introduce today's speaker, Edward Doan and Sarosh Naseem. Sorry if I don't pronounce your name correctly. So both of them are from Google. They are experts in Google Cloud computing platform, and they work to help higher education and research institute to use Google Cloud. So Edward is also currently a adjunct professor at UT Austin. So I guess that's my introduction. I will hand it to Edward and Sarosh. Okay, and I will mute myself.
All right, thank you very much. Sarosh, do you want to start when I show your screen? You don't need to do that.
If you don't mind doing that, and also your voice is lagging a little bit. I'm not sure why is that.
Excuse me.
So before we get into the meat of the presentation, I joined 10 minutes early and chatting, and it became clear to us that it would probably make a little bit sense for us to talk a little bit about our business and which organization we represent and what our engagement strategy has been. So I'm going to take a quick minute to introduce myself and our team. So my name is Sarosh Naseem, and I'm an account executive in the Google Cloud team. Along with Edward Doan, we are responsible for working with higher education and research institutes in the West. When we look at our engagement strategy, there are three tenets of our engagement strategy. The first one is to work with the central IT and central IT type workloads, things like student information system, learning management, ERP. The second, and probably the most important piece of our engagement, is with research, and that's where we spend a whole lot of time. In fact, 70% of our business is working either directly with the researchers across various domains or working with the research computing. And the third part of our engagement is essentially enabling teaching and learning across various institutions. So a lot of what we're going to talk about today will be focused on HPC per se, but feel free to jump in and ask any questions. I'm also hoping that most of the individuals here, they're somewhat familiar with cloud and Google Cloud. If that is not the case, please let us know. So at least we'll start there. And if people have a general understanding of Google Cloud, then we can jump right into HPC in Google Cloud. Okay. Ed, over to you, sir.
All right, hey everyone. So yeah, as mentioned, I'm the customer engineer, and I've got the technical responsibility for looking after Google Cloud with our university accounts. I guess, do folks see my screen? Do you see my slides?
Actually, no. Okay, we can see the slides now.
You can. Okay, perfect. All right. So today we'll be talking about HPC and Google Cloud, how Google Cloud is different than some of the other cloud service providers, and then some of the solutions that might work for your use case, and then some case studies. So talking about HPC, I think as you guys know, competition for funding within NSF and NIH is growing, and their proposal success rate is actually, it's shrinking. Sarosh and I were just at supercomputing in Dallas this past week, And this was sort of a theme we were hearing. And so I guess it's definitely a driver for increased access to high performance computing resources, because especially among the leadership class supercomputing clusters, even the newest Exceed cluster member, Frontera at TAC in Austin, they're including Google Cloud as part of their offering, just because they need to have that augmented capacity and capability that would exceed, pun not intended, that would exceed what they can build in a traditional manner. And so researchers are also seeking bigger scale problems. As an example of myself personally, I worked with University of Southern California just the other week, and they were doing a drug discovery experiment that they were looking for on the order of 100,000 CPU cores for 48 hours. And in order to squeeze in that time onto one of the national supercomputing clusters, they would probably have to wait, weeks and weeks, if not months, right? But they were able to come to Google Cloud, get their results. Is my voice here? Let me check my mic.
Okay, how's this? Are you guys able to hear me?
This is better. Yeah, it's
Sarosh,
better.
anyone? All right, how about this? Can you guys hear me if I do this?
It's louder, but it's still breaking.
Is breaking. Okay. That's weird.
Do you want to try turning off your
okay,
video?
Yeah, perhaps turning off your.
Yeah, maybe. Do it.
Actually,
Alright.
let me also try to turn off my video.
Okay, hold on. How about now? Since any better? I just turned off my video.
Yeah, much better, much better.
Okay. Maybe it's a bandwidth problem on my side. And so, yeah, compute needs are growing. I think you guys, if you've followed the top 500 list, you'll see that it's a linear increase in computation capability. And I think, right now everyone's, the goal, of course, that's within sight is the exaflop. And so that's only a matter of time. I mean, myself personally, I came before Google 8 years ago. I worked at IBM, where I worked on what was at the time the #1 supercomputer, Roadrunner, which was the first to crack a petaflop. We thought that was a huge accomplishment, and already in just 10 years, we've exceeded that by 2 orders of magnitude for the #1 system. So I think it's a matter of time before we get to exaflop. And so historically, as you probably know, the HPC is very expensive, right? To run, you can run small HPC, but you'll get small results. If you want big results, you got to run big HPC, and that's very expensive. I mean, you can see to run some of the national leadership class supercomputers, it's in the hundreds of millions of dollars in terms of setup. And so and the other problem with traditional HPC, of course, is that if you have a single cluster, you've got a single queue, or at least only 1 or 2 queues, and people are waiting to get time onto that scarce resource. And whereas, what we're proposing with Google Cloud is that it's not a single cluster, it's n number of clusters that you can set up and tear down on an as-needed basis. And the idea is that you can have a tailored cluster that is custom fit to the use case without having a queue, and then your users are going to be happy because they can just, like the researcher at University of Southern California, he was able to hop on do his work and get off in order to start doing the analysis and writing of the research paper. Any questions so far? Like, is this kind of, you guys are looking at some of the HPC resources on this, leadership scale? Is this relevant to you?
So other people may have better comments, but for myself, I guess, at least for the jobs that I've seen, I actually think the smaller scale cluster that we can just start on the cloud, they are probably the most productive one, because most of our jobs are less than 1,000 cores, so we don't really need the leading supercomputers, but other people may have their other kind of workflows.
Yeah, and I understand, one of SpaceTrek's use cases is to look at the artificial neural networks, right? And so almost like a variation on deep learning. So
actually, we discussed a little bit before the webinar start. So this is actually the we are talking about the PIRE project, and one of the focus we have is the Event Horizon Telescope. That,
yes.
That we need to try to take the first picture of black hole, and we also do numerical simulations of black holes. So yeah, okay. Yeah. So maybe I can throw in a question here. So for the Google Cloud platform, what kind of interconnect you have for HPC? Is that just your standard Ethernet, or do you have your InfiniBand, or what is the bandwidth you can?
Yeah, right. Good question. So the node-to-node interconnects, it is Google's own software-defined network, and we offer 40 gigabits per second node-to-node bandwidth. Latency is, I will say, InfiniBand has, if you need single-digit microsecond latency, then InfiniBand is still your best choice, and we don't have that. What we do have is node-to-node is going to be low double-digit, like in the like 15 to 18 microsecond latency. But that said, one thing we offer that is potentially interesting, though, is you don't need these fast interconnects if you can get away with a denser node. So right now, our densest standard configuration is 96 cores on one motherboard, and we have, that's coming out very soon, 160 CPUs, or 160 cores on one node. And so if your jobs can be partitioned to fit, 160 threads, for example, in one unit, then you can run that on one single motherboard, and then you don't need the, like 8 microsecond node-to-node latency as much. The other thing that is potentially interesting is that if your job, particularly the numerical analysis or black hole simulation, a lot of those I understand are very data intensive. We can scale all the way up to 3.8 terabytes of RAM on one node.
Okay, that's very good. And just to let other people know, the EHT part of the PIRE, we actually routinely using the 96 core virtual machines to do our calibration. And some of us at Harvard also try to start testing those really big high memory machines, and we are pretty happy with those. So yeah, okay, so yeah, thanks. Please keep going.
Okay. So yeah, I think this is I kind of talked about this already, but it's again the high utilization versus low utilization times. Instead of having a fixed resource, we're offering a flexible resource. And so advantages of Google Cloud specific to HPC. By the way, I should ask, were any of you at Supercomputing in Dallas this week? No one? It was actually a pretty good show. The Google booth alone was very, I should say, well attended, well subscribed, and a lot of people were understanding that it's because of these reasons. They want to learn more about Google's capabilities in terms of compute. I mean, you need thousands of VMs in regions all across the world. That's something we can do very, very quickly. The Jensen Huang, founder of NVIDIA, was actually on stage the first day of supercomputing to announce NVIDIA's newest GPU, the T4, is available today on Google Cloud. And so that's, I mean, most people can't even get that GPU, for end user purposes, but it's already available on Google Cloud for you to use on a hourly basis. I mean, you're paying just for the exact time you need it instead of $25,000 for this GPU as a sunk cost.
That's awesome. In Arizona, we do a lot of black hole ray tracing on GPUs, so that we will be very excited to try those hardware.
Yeah, the GPU, and I'll talk more about this in a moment. We have a lot of companies in all kinds of different use cases, for whatever, I guess it's maybe a similar use case, seismology. The oil and gas companies really love the GPUs. And I think maybe that's it's obviously a different use case, but that's looking down into the ground instead of looking up in space. But nonetheless, they need to use the GPU's numerical floating point capabilities in order to do their discovery. And then, the other thing to think about, of course, cost. Not only is the cost structure flexible with Google Cloud, but compared to other cloud providers, we think you will find a cost advantage with Google, and we'll explain that in a little bit. Storage, lots of storage available, and then of course this one is I'd kind of like to learn more in a little bit from your team, but some of the HPC tools that you might be using today, we've heard from a lot of schools and a lot of enterprises using HPC that want a specific tool, whether that's Altair PBS or Slurm or Torque, Condor, all these workload managers, for example. They want to be able to use it in the cloud the same way they use it with their traditional cluster. And so one of the advantages of being Google is that we can go out to these companies and say, hey, we'd like you to bring your tool to our platform. So we did that most recently with SCADMD, the makers of Slurm. Are you guys using Slurm today as a workload manager on your cluster?
So I don't use it, but other people may have used it.
Yeah, we use it too.
Are you still there, Ed?
Anybody still on?
Looks like we lost Ed. Hang on a
Okay.
second. Let's just see, where is he at? I see that he's still on. Must have been having issues with connection drop, rejoining. Okay. So while he's rejoining, I know some of the individuals here had experience with Google Cloud. Anything that has struck out for you folks when you're working with either compute and storage, or in general just the account management, asset provisioning? How do you provision storage buckets, and the usability of Google Cloud Platform? If you can answer.
Well, I personally have never used Google Cloud myself, so I'm familiar with the basic concept, but I have no practical experience.
Gotcha. And one of the things we do as part of our engagement strategy is to help train our customers. So when we engage with institutions like ASU or University of
Oh,
Arizona.
hey guys, I'm back. Oh, can you hear me okay now?
Yeah, we can hear you. Perfect. You may want to mute your video because it'll.
Well, all right, hold on. Hang on, let me go back to my screen share here. Sorry, Sarosh, go on.
Yeah, I was just answering a question there. So, you know, with institutions, we have both online and in-house training options. So depending on, you know, where the, you know, the geolocation of the participants are, you know, we can figure out a way to sort of enable the learning for the audience. So for this particular group, since this is very distributed across different institutions, we can figure out an online credit type situation for either Coursera or Quick Labs. So that'll help you sort of get going. But we can cover some concepts. So since Ed is back, we can continue to focus on HPC.
Yeah, so you guys still hear me okay, right? Yeah? Am I breaking up at all?
You're good.
Okay, perfect. So yeah, just getting your computation done, not building and managing infrastructure. You know, very relevant to space tracks. I don't think you get any value out of building and maintaining clusters. You get value out of launching stuff, making observations, and then writing incredible discoveries that I myself, as a amateur space geek, I love reading about on space.com. So just things to kind of go through quickly is, you know, 1 billion users across Google's products. The reason we did Google Cloud is because we want to be able to take the same infrastructure that powers YouTube and Gmail and search and Google Maps and be able to use that powerful infrastructure and share it with the world. Security. So, I mean, look, security, the picture on the left represents typical enterprise capability for security. You have a very hardened outside. Once you get past that outside layer, your inside is very soft and gooey, right? On the right-hand side, just talking about Google's security stack, we refer to this as defense in depth. Each layer of Google stack is custom designed in-house. I mean, the only commodity part that we use really are Intel processors. We even design our own networking chips, our own routers, our own switches. The Linux kernel is customized. Motherboards are all designed by Google. And the reason we do all this is so that we can ensure vertical integration and make sure that every piece is secure and reviewed, you know, audited for security. And as a part of those audits, you know, we've been able to achieve numerous certifications. You know, we're FedRAMP moderate compliant, and so we can work with U.S. government workloads even. HIPAA, PCI for healthcare and financial services, respectively. These are all certifications that Google Cloud has. Within your particular use case, do you have any certifications that are required?
So I guess sorry, I hear my echo. So I guess we don't have any requirement, but you know, speaking about security, you know, it would be really great if we can get some Google engineers to advise and help out, you know, to design our infrastructure to make it more secure. So you know, for example, you right now many of our data actually protect just by shared passwords. So that's something we for sure want to improve.
Yeah.
Yeah. So if there's a way to get us connect with your security team and find a better way to handle our data, that would be very useful for us.
Yeah, absolutely. I mean, I'm happy myself to advise on that. For example, I work across many universities, and I'm the lead Google engineer working on the NIH Data Commons project, for example. And so NIH, of course, is working with healthcare data and HIPAA protected data. And so we are advising them on ways to protect that data because NIH working with the Veterans Administration, healthcare data is obviously needs to be very secure. So I think the core offering that you guys would be interested in would be what we call Google Compute Engine. This is our virtual machine offering. And as I mentioned, we scaled up to 160 cores, 3.8 terabytes of RAM. The workloads, we can do batch computing. High throughput computing is something that we definitely excel at, and that's where you get the massively parallel, but not necessarily interconnected workloads. Real-time workloads, we do lots of things with IoT. Speaking of which, one of our current use cases, customers that we're working with, is LSST. And so they are starting work with Google Cloud to be able to send observatory data and stream it into the cloud to be able to store on their databases. And it is also a multi-institution, multinational effort. And so they need to be able to have the data be accessible by different groups across the world with good latency. And so if you have a collaborator in South America, you don't want to have 100 millisecond latency to do a database access. And so that's one of the reasons why LSST is working with Google. Price, we offer all kinds of different discounting structures that can provide a good cost advantage to you. The sustained use discount is automatic. That's basically if you leave a machine running for more than 24 hours, we automatically start applying discounts to you. The other things are, we like to think we offer better list pricing to start with, and custom machine types. This is potentially something interesting to you, because if your application needs a configuration that is not one of the standard configurations, let's say you need 35 threads, there's no 35 core machine, you can set one up on Google Cloud. And so we offer sliders that let you just choose number of CPU, amount of RAM, number of GPU. This is all customizable. This is where, so the preemptible VM, some of you may be familiar with AWS Spot instances. This is analogous to that concept. You're basically paying economy class instead of first class fares, but instead of having to bid a certain amount to get access to a VM, we just offer straight 80% discount on our fixed pricing. And that way, if you're using so if your workload is not you value price over having the VM always be available, then you're paying, like I said, sort of like an economy class fare where, we could overbook the cabin, but your job will eventually run. And in exchange for, or you may just go and not have to deal with being bumped off, but in exchange for that, you'll save 80% off. So this is actually the way most of the academic large-scale clusters on Google Cloud are operating is with a preemptible VM. They will assign tasks in their work queue to the nodes, and then the nodes have regular checkpoints and can resume from that checkpoint if the node gets preempted.
So one technical question on the preempt VMs.
Yes.
Especially in the context of HPC. So suppose I launch multiple VMs that I want to run a big MPI job on that. Then preempting one of the VMs will break the whole MPI jobs. So is there any trick or any other type of ways to deal with this? So if it's preempted, then just preempt the whole MPI cluster instead of preempting one, or or things like that.
Well, in that case, I probably would not recommend running preemptible if you have a strong dependency between nodes. But what you could do is run almost like MPI on a single node. With 160 cores, you could run MPI on a single node and have it just be very, very fast, because obviously chip-to-chip communications on the same motherboard is fast. And then if that node gets preempted, then that particular MPI job will go down, but then the other ones keep running, and then eventually that node will come back, and you can run to completion. So this one, I would say, would be very useful if you have a highly parallel problem. So an example of this might be, when we worked with NASA on Kepler, doing that the image classification in the search for the exoplanets, we're able to break up the task into thousands of nodes, each running independently on its own data set. So do you see what I'm saying there? It's so if each node is independent, then you don't care if node 447 goes down, it can come back at some point.
Okay, that sounds good. Thanks.
Yep. Operating systems, we've got lots of them. Skylake architecture, we work directly with Intel on optimization for Skylake. I don't know if you guys are you working with Intel or NVIDIA on your use case?
Intel in our case.
Okay, are you working directly with them?
No, we're running a local cluster here that has Intel processors, but that's
okay. Got it. Yeah, I mean, given the high-profile nature of space treks, what we can, Sarosh and I can also do is we can bring in experts from Intel or NVIDIA to help optimize your workload for that architecture. Yeah, and so with obviously slightly different fit between Intel and NVIDIA, depending if you need the CPU or GPU resource. If it's a GPU resource, as I mentioned, we have the P100, V100, V4, T4. You tell us, which one of these accelerators can help your use case. And then the other thing I should mention is that, like the VMs, we also offer the GPU on a preemptible basis. In this case, it's 50% off. I mean, the cheapest GPU, the K80, I can tell you runs about 29 cents for 1 hour. TPU, are you doing any machine learning in your application today?
So not for myself, but I do know there are many groups in the University of Arizona using machine learning. So.
Okay. Yeah, I mean, the fact that you're running a neural network for the robotics, you're, you know, with the search for black holes, you know, I don't know if it's applicable to run machine learning, but if you're doing anything with TensorFlow in particular, Google has a hardware accelerator called Tensor Processing Unit. This is order of magnitude faster than even GPU for machine learning. Okay, so networking, you know, networking is great, as I mentioned. And I think the other thing to mention is your group is globally distributed, and Google's network is the largest non-ISP network in the world. And so we're able to help connect your the different institutions in your group all across the world with very high bandwidth. Here's something that is potentially interesting to you. Because University of Arizona is part of Internet 2, we give, you know, to all Internet 2 members, we can waive the data egress charges. So one of the objections to cloud historically is that, oh, it's expensive if I want to move data out of the cloud. So yes, there is an egress charge, but if you're an Internet 2 member, we remove that obstacle for you.
This is awesome, and I didn't know about this.
Yeah, so this is, and we're also peered with Internet 2 at layer 2 as well as layer 3. And so you're already, University of Arizona being I2 member, you're already only one hop away from Google Cloud. And if you want to do a direct connection to Google Cloud, you can even do that. You can plug in at an internet exchange directly to us. Okay, storage, you know, we offer lots of storage. Whether you want very, very fast SSD or you need a massive amount of low cost archival storage, we can be that provider for you. Yep, and these are some of the solutions that the partner solutions that we work with across the HPC space. And so, you know, if there's someone that you work with who's not on this list, then, you know, we definitely want to find out. But otherwise, we think this is a pretty comprehensive list of partners. All right. And yeah, so Slurm, as I mentioned, workload manager. One of the things that's interesting about the workload manager, I should say, is that we have this ability to burst to cloud and federate with cloud. And what that means is that if you're, if you have an existing cluster that's using Slurm, then you can make Google Cloud an extension of that cluster. So one thing I hear a lot from universities, you know, so you mentioned having 1,000 nodes, for example, or I think 1,000 nodes or 1,000 cores. But let's say it's 1,000 cores, right? If you have a problem that requires 10,000 or 15,000 cores, right? Then then the idea is that you should not, your resources available should not constrain your researchers. But at the same time, they may already be accustomed to working with the existing cluster on premise. They don't want to change their tooling or their access. And this is where the workload manager comes in. It can make the on-premise cluster look like it has 50,000 cores available, even though it really only has 1,000 on-premise. It can supplement using cloud. And so using some parameters or manual redirection, an HPC cluster manager can direct the job to go to cloud instead of going on-premise. The same thing goes like if you have only 20 GPUs, but you have a job that needs 100 GPUs, then Workload Manager can direct that job to cloud, and then pull the results back and store it locally if you need to. So some of the customers that we've worked with, Fermilab, we worked with, in this case, it was with the Large Hadron Collider, and the architecture involved there was we worked with the existing cluster at Fermilab to partition off parts of the job that were too big for their on-premise cluster to handle, and we sent it to the preemptible VMs within the Google Cloud. And what the result was is they were able to, the purple bars indicate additional cores from Google Cloud. And so they were able to ultimately hit over 300,000 concurrent cores in between all the cores available at CERN, at Purdue, at MIT, and then plus Google Cloud. They're able to hit the concurrency that was needed to work on that particular problem. And then MIT is another customer that was able to use a massive amount of resources for a very short amount of time, over 500,000 cores for one afternoon to solve, I believe it was an hyperelliptic curve cryptography problem. Just turn on the resource and then solve the problem and turn it off when you're done. So that's kind of what I had for this morning. Want to hear if you guys have any questions, or we can start discussing the specifics of your use case.
So thank you very, very much, Edward. So I hear that someone need to leave early. So I wonder if they have any specific questions and comment for this webinar.
Yes, indeed, I have. I'm speaking here for Max Planck Institute in Germany, so my use case might be different than for the other participants here. So our main use case is VLBI data correlation, and it doesn't require many cores. So in fact, we are running a local cluster with about 1,400 cores, and that is sufficient to what we want to do. Going to a cloud might be interesting from different points of view, that we could save investment costs and maintenance costs of the cluster and so on. So we have looked into this in the past on a few occasions, and there were two showstoppers always, and I wonder if anything has changed. So one showstopper is the huge amount of data that we need to process, and it's in the regime of 5 to 7 petabytes per run. So that would need to be A, transferred to the cloud, and B, paid for to be stored there for a period of, let's say, weeks. And we always found that was not feasible. So my main interest is to see if there's anything on the horizon that would change that situation.
Potentially, yes. So we do have a physical appliance that can store 480 terabytes per appliance. And so you could conceivably get multiple units of this appliance, plug it into your rack, copy the data, and then ship it via DHL or FedEx to a Google data center for ingest. And that would be, depending on the size of your internet connection, that could be faster. 5 in the regime in the range of 5 to 7 petabytes. I would guess that a DHL truck has more bandwidth than your pipe.
Yes. That's how we do it. I mean, and that's how we get the data to the correlator too from the different telescopes. It's shipped by truck.
And once the computation happens, then if this is just input data, then you can just erase it. Treat the cloud storage as like scratch space, right? It just depends on you. Or the other thing is, if this 5 to 7 petabytes is actually very valuable data, you can maintain it in what we call cold storage. That's our deep archival tier that could be cheaper than maintaining a storage appliance on your at your location that can hold 7 petabytes.
Yes. So if I understand the concept correctly, I never heard about this. So this appliance is a dedicated piece of hardware that would have to be installed at our cluster, where we can store the data, and then we ship it to you, and you can then work on it. Okay.
Yeah, it's a 2U rack mount box that's just full of disks.
Okay, I see.
Let's see. So Nirav, cost can be apportioned or controlled per user when integrated with traditional HPC. So cost, yes. So the short answer is yes, but it depends. If it's on the, so Google Cloud does have a cost attribution tool. So cost management tool, Orbitera. And this cost management tool can be used with Google, Amazon, Microsoft, IBM, or even on-premise clusters. And as long as each of those systems has an API or some other way of exporting cost, right? So all the cloud providers have a mechanism for doing this because obviously it's important to be able to attribute cost to a particular lab or researcher. And then in terms of large analysis in cost overruns, yes. So Google Cloud does offer the ability to set budgets, and you can set a budget, like say you only have $5,000 available. We can send you alerts when you've spent 50% of that, 75, 80, 90, 95, etc. Send as an email or SMS, and then so you know to stop the whatever job or process is consuming that much money. The more typical case I see for cost overrun, frankly, is a graduate student leaves a cluster running idle over the weekend.
Okay. That sounds interesting. I will have a look into this a bit more. Thank you.
So actually, before you go, so let me also give you an update about some development with SAO and Google. So Shep always talk about this cloud correlation thing. So actually, when I'm the person who started the initial work. And Sarosh, who was a summer student last year at the SAO, he also helped out the initial work. But both of us are in Arizona now. So the idea there is we want to figure out how fast and how costly it will be to do the correlation on the cloud, and we figure out storage and data transfer were the major factor. So we use our initial benchmark to put onto a NSF proposal, and the proposal got funded, and now we are partnering with Google to develop the next generation of data transfer appliance. So I guess this is still in the progress, so probably not everyone know about it, but the idea is if we can use the Google data transfer appliance directly, put them into the telescope, then that can save us even more money, and that will be beneficial for both astronomers and Google. So that's pretty much about that part.
Yeah, how are you doing it today to get data out of the telescope?
So at the moment, there's special hardware recorders at each station, and it's a bit similar, I guess, to your appliance concept. So they stick in hard disk modules where you can do very high speed recording. So we have to record data. Oops, somebody's echoing really badly. We have to record data at 16 gigabits per second. So it's special hardware needed, and I'm not sure if appliance at the moment could do that. So maybe that's part of the research there. But so at the moment, there's special hardware doing this, and these disk modules get shipped to the correlators, where we have similar units for playback. So the concept sounds similar to what you're doing at Google Cloud, but it's dedicated special kind of machinery at the moment.
It sounds, my guess is it is expensive and hard to maintain.
It's not too expensive. Of course, hard disk modules, I mean, the cost of hard disk is a major investment. It's more of a logistical effort to do that, but that would be the same using appliances, or maybe possibly better. I mean, at the moment, the disk modules that we're using, they're in the order of 80, between 64 and 100 terabytes per module. So
okay,
if one can use 48 terabytes in one go, of course, that would kind of ease the pains of logistics. But
yes,
the question is if the data rates would be sufficient with existing appliance technology to do that.
Okay, so you're saying 16 gigabits per second is your
yes,
write
times
speed?
4. So there's 4 units that do parallel recording. So in the end, we do 64 gigabits per second, but it's in 4 independent units, with each of them receiving streams of 16 gigabits per second, and they have to record them in real time.
Okay. Wow, that's very fast data transfer. And you're not using SSD for this?
Too expensive at the moment.
Yeah, it's expensive, of course, but okay, I'm impressed if spinning disk can keep up with that. Yeah, that's
yes,
probably right on the edge of spinning disk.
Well, you have 4 modules per unit, so this is how you use 32 hard disks that record in parallel. This is how
it's in parallel. Okay, good. Any other questions, or Sarosh, is there anything you wanted to ask?
Okay, I will sign off. Thanks a lot for the information. It was very, very interesting. Thank you.
All right, thank you.
Bye. Yeah, so we are at the hour. So if people have to go, then you feel free to sign off. But for the people who can stay, I wonder if people still have more technical questions on doing HPC on the cloud, so please bring that up. But if not, then I also want to have the opportunity to talk about your partnership and training with Google. So I saw Demetrius is back in his office. So Demetrius, do you want to say something?
I'm sorry, I was just listening over on my phone as I was driving my children to school this morning, and there are a lot of technical issues that I listened to, and I had a lot of questions. So I'm hoping, Ed, that we will be able to keep this communication channel going.
Oh yes.
Especially the thing that was most interesting to me is the possibility of doing non-trivially parallelizable things that I understand is easy to do on the Google Cloud, but highly interconnected cases, because this is the second half of what we do, with a large number of cluster of nodes, and see how to make that work with Google. But this is something that we can take offline. I guess the other question is, if we, I guess I wonder, Sticky, whether you're talking about the practicalities or the financial aspect of the interaction.
So I was, yeah, please go ahead.
No, go ahead. Go ahead.
Yeah, I guess for me, we have different type of workloads. So instead of thinking about, if Google Cloud will be useful for us, I guess the question I ask is, what kind of workloads that we have make sense to both financial sense and technical sense to put on Google Cloud. But so that's the technical part. But on the other hand, we also need a lot of trained scientists and students to work on this. So yeah, I guess we should discuss both of this.
Yeah, these are both good points. And I think the second point is where our particular program becomes important here, because for two reasons. One is that we're all working at a very high pace of needing to generate results, scientific results. And for us, this is a tool as opposed to a development platform. But the second, and of course, that leads us to usually the way that we work is that we use existing tools, and there's a lot of inertia in updating and moving to different platforms and different ways of analyzing our work or doing our work. You might have heard that still more than 70% of algorithms in astronomy are written in Fortran 77 on spaghetti code. So I think CK is correct. Is there any way to get some input from Google of engaging the younger generation, the younger students and postdocs and younger researchers, and educating them in how to use these platforms?
100% yes. And we want to make training available at all levels as accessible as possible. And so I will say, for example, in especially in computer science classes, and even if any of your, if you're teaching any class, we can offer credits for you to use Google Cloud for free. And so, for example, at the University of California, Berkeley, they have, I think they have the largest data science class in the United States. And all the students learning about Jupyter notebooks and R and MATLAB and all these data science tools, they can run on Google Cloud for free. And in addition to that, we can also make training available either in person if you have a regular, if you have an opportunity to everyone meet in person, we can certainly arrange for an instructor to fly out and meet you, or we can do something virtually via a remote like Zoom or Hangouts, and we can do a class that way. But as much as we can, we'd like to make training available. Asking if we can unmute him. He's on the phone. Is there a way to unmute someone who's on the phone?
You cannot unmute on the phone, unfortunately, with Zoom. That was my problem. I couldn't talk while I was on the phone.
Oh, okay. So phone participants cannot be unmuted. Okay, yeah. I understand.
Yeah. So okay. This is a good point that you brought up, because we have two ways to make that happen. One is that we have quasi-monthly hackathons in this project, and we can always arrange for one or two of them to be led by one of the people from your side of the expertise, and train people how to use Google Cloud. The second thing that we do is that we meet once a year as in a summer/winter school. And actually, I guess in some ways I wish this was an option that we discussed earlier. We have our very first winter school on HPC a month from now here in Tucson.
Oh, and okay.
It is kind of, the schedule is arranged, but I wonder if that's something that, if it is too late to get something like that going as well.
If it's a month from now, then possibly not too late. Just send the information over to Sarosh and I, and we can discuss the what's needed and the logistics involved.
Yeah, because the way that we handle it is that we have a couple of morning lectures each day, and then in the afternoon it's everybody on their computers and doing exercises and trying out to solve some simple cases and make sure that they understand the various tools. And this is mostly based on code optimization, but of course access to Google Cloud would be something that would be of extreme use. So let's talk about that in the next couple of days to see if there's a way to incorporate it, because this school is happening here in Arizona based on that, and it's an easy fly from wherever you guys are.
Yeah, I'm in Texas. I'm in Austin, and Sarosh is in Bay Area, so exactly. Arizona is halfway.
Yeah, and the next ones will be international, which might be more fun. Some of them are going to be in Taiwan, some of them are going to be in Mexico, but maybe we can. Let's talk about how to start something sooner than later, because that would be a very useful case for us.
That's fantastic. Yes.
Thank you.
All right. Anything else, or BK? Anything from your end?
So let's see. Yeah, I guess Demetrius mentioned that we hope that you can help out in the winter school, but I guess in the longer term, we wonder if anything can be done. So you already mentioned the classroom, the Google credit for classrooms. So but for our project, it's a little bit tricky because we don't actually teach class. We have students joining us that we train them, and we would love to provide them Google Cloud resource for them to work on, but they are not officially in a class. So is that something we can also coordinate with?
Possibly. So let me understand. Space Treks, is it funded by NSF?
So actually it's called PIRE.
PIRE.
It's also NSF funded. Okay. And on top of the research, we talk about education is a big thing, and and we also have undergrad students joining us that we pretty much give them your cutting edge astronomy project to work on. So right now we give them your local HPC resource, but we also understand that your cloud computing is big, and for them to get their after they graduate, in order to get a good job, having some experience with your Google Cloud will be really good for them.
Yes. Yes, we can definitely discuss a mechanism to help your students with. I mean, I think the main distinction. I'm trying to think. How do I put this? We give away credits for free for teaching all day long. Research, we can provide some level of what I would describe as seed funding, which would hopefully then get you to the point where, get a graduate student to where they can write a proposal for a grant, for example. But, the way that, me personally, the way that, I get credit, I get attainment, my contribution to Google Cloud is by working with large research projects that are NSF funded, and they're using their funding instead of buying a cluster. They might use that money on Google Cloud to get the resources for the duration of their project. Does that make sense?
Yes, that makes sense. I see it.
Okay.
Mm-hmm. So let's see. Okay, so Liref just dropped off. So yeah. He's leading Cyrus, so you probably know about that. It's also a big cloud computing infrastructure, and they do a lot of training. So I shouldn't speak for Cyrus, but I wonder if there things that people can work together for. Yeah, but since Liref is not here, so maybe we can hold off that discussion.
Okay, that's fine. Yeah, we could definitely continue via email, or if you want to set up another time to discuss after the Thanksgiving holiday, I would be happy to do so.
Okay. So I guess that's all the things I have. So Demetrius, do you have more to?
I think it was great. Thank you very much to both of you. This was extremely valuable and informative, and we will stay in touch short term and long term, and let's try to make this happen.
That's wonderful, guys. I really appreciate this. I'm super excited myself, as not just as a Googler, but also as an amateur astronomer. I'm very interested in this use case, and so reading about how Google Cloud helps out with Kepler and MSST and hopefully PIRE, this makes me very happy.
Okay, that's wonderful. Thank you very much.